Welcome to Science for Sleep, where we explore the mysteries of the universe at a pace that's calm and soothing, perfect for winding down. If you're new to our channel, don't forget to subscribe and join us on this quiet journey through the cosmos. Tonight, we're tackling a question that stirs the imagination and sparks curiosity. Why is it impossible for aliens to ever reach Earth? You may have wondered about the possibility of extraterrestrial visitors, or whether civilizations exist out there in the vastness of space. But tonight, we'll focus not on whether aliens exist, but on why no civilization, no matter how advanced, could ever travel across the vast cosmic distances that separate us. The answer lies not in the limitations of our technology, but in the very fabric of space, time, and physics itself. So, sit back and relax. Tonight's story is one of awe, wonder, and some harsh realities about the scale of our universe. Let's begin. When we gaze up at the night sky, it's easy to imagine the stars as distant neighbors, scattered across the cosmos like shining jewels. The beauty of a star-filled sky is unmatched, but that beauty comes with an optical illusion. Look at two stars that seem to be right next to each other, almost touching. From our perspective on Earth, they might look like neighbors. Your mind tells you that they're nearby, just a small gap away. But in reality, that's one of the biggest lies the universe tells us. These two stars may be light years apart, with distances so vast that the human mind struggles to grasp their true scale. One might be a red dwarf, a relatively dim and small star, located just 6 light-years away. The other could be a massive blue supergiant, blazing across the sky from 800 light-years out. Despite looking close, they are light-years apart, and each exists in its own part of the galaxy. They don't even reside in the same spiral arm of the Milky Way. The night sky flattens out space, turning it into a 2D canvas that we can process visually. But space is anything but flat. The trillions of miles separating these stars are unimaginable. This illusion gives us the false impression that the stars are closer, making the prospect of interstellar travel seem more plausible. But it's a dangerous misconception, as we'll soon see. This cognitive shortcut goes deeper than just the stars. Humans evolved with a visual system designed to measure nearby distances, whether that's estimating the distance between two objects in the same room, or judging the gap between a predator and a prey. Our brains weren't designed to measure distances in the trillions of miles. When we look at the night sky, our brains simplify the mind-boggling distances between stars into something manageable, collapsing what's essentially an infinite expanse into a flat image. This flattening of space is a fundamental part of how we process our environment. It's what allows us to navigate the world we live in, but it also creates a huge gap between how we perceive distance and the true scale of the universe. This illusion can trick us into thinking stars are close, which plays a central role in how we think about space exploration. Imagine alien civilizations. It's easy to picture them traveling from one star to another, just as we travel across our planet. But the truth is, even our closest star neighbor, Alpha Centauri, is so far away that the idea of visiting it seems more like science fiction than science fact. To help us grasp just how far Alpha Centauri really is, let's break it down. Alpha Centauri sits 4.24 light-years away from us, Now, a light year is 5.88 trillion miles. So, when you multiply 4.24 by that number, you end up with a mind-blowing 25 trillion miles, the distance between us and the closest star to Earth. Here's where it gets hard to imagine. Even if you could count from 1 to 25 trillion, one number per second, you'd need to spend 800,000 years doing it. Let that sink in. 800,000 years. You would begin before anatomically modern humans even appeared on Earth, and by the time you finished, the world would be unrecognizable. Now, let's compare that to a spacecraft that's been traveling through space for over 40 years. Voyager 1. It's currently the farthest human-made object from Earth and travels at around 38,000 miles per hour, which is about 22 times faster than a bullet. But despite all that speed, Voyager has covered only about 15 billion miles, a fraction of a light day. A single light day is a mere 1/365th of a light year, and Alpha Centauri is over 4 light-years away. If Voyager 1 were to continue at its current pace, it would take 73,000 years just to reach Alpha Centauri. And even then, it wouldn't stop. It would just sail right past, continuing its lonely journey into the emptiness of space. Imagine waiting 73,000 years for an alien probe to reach us. In that time, humanity would have lived through thousands of generations, multiple cultural revolutions, and technological changes. The probe would arrive after all of that, and still pass us by. Now, Alpha Centauri is our closest neighbor, but the Milky Way is so vast that it spans roughly 100,000 light-years across. To cross the entire galaxy, light, the fastest thing in the universe, would still take 100,000 years. That's 100,000 years for light to travel from one edge of our galaxy to the other. Even though light travels at an incredible speed of 670 million miles per hour, it's still not enough to cross the entire galaxy in a human lifetime. In fact, a single human lifetime, about 80 years, is 1,250th of the time it takes light to cross the galaxy. This gives you a real sense of just how huge the Milky Way is, and we are just one galaxy among billions. Now, let's extend our view beyond the Milky Way. The nearest major galaxy to us, Andromeda, is about 2.5 million light-years away, and in the observable universe, there are an estimated 2 trillion galaxies, each spread across 93 billion light-years of space. These numbers are so far beyond human comprehension that they exist almost like abstract concepts rather than tangible distances. To illustrate, imagine shrinking the Milky Way to the size of the United States. At this scale, each star is like a tiny grain of dust. Our Sun would be a grain about 4 inches from Alpha Centauri, but the next star could be 100 feet away. And stars spread out across the galaxy would be like scattered grains, surrounded by empty space. But this vast emptiness between stars is what we often miss when imagining space travel. It's not just far, it's empty, dark, and cold, with no landmarks and no way to orient yourself. Even the interstellar medium between stars is thin, consisting of about 1 atom per cubic centimeter. In comparison, the air we breathe contains 25 quintillion molecules per cubic centimeter. This emptiness creates a monumental barrier that no amount of technology can simply overcome. Now that we've established just how vast the distances are between stars, let's tackle the next challenge: speed. While we may think of interstellar travel as something that could be achieved with enough time and technological innovation, the truth is that the speed required to make even the nearest star reachable within a reasonable time frame is simply out of reach. And it's not just about going fast. It's about how much energy is required to make that journey possible. Let's start by looking at the speed of light, the fastest thing in the universe. Light travels at an astonishing 670 million miles per hour, or about 300,000 kilometers per second. It seems like this should be fast enough to reach any star in the galaxy. But let's take a closer look at why this isn't the case. Even though light is the fastest thing in the universe, it's still not fast enough to cross the Milky Way in a human lifetime. At 670 million miles per hour, it would take light 100,000 years to travel across our galaxy. The same galaxy that contains billions of stars. This is the scale we're dealing with. Light needs tens of thousands of years just to cross our local galaxy, and it's the fastest thing we know of. Now, imagine trying to travel at a fraction of light speed, which realistically is what we'd need to do in order to make interstellar travel even remotely possible. Even if we could travel it at 1% of the speed of light, that's around 6.7 million miles per hour. It would still take us 73 years to reach Alpha Centauri, the closest star system to our own. If we managed to travel at 10% of the speed of light, which is 67 million miles per hour, it would take us 730 years to reach Alpha Centauri. Even though this may sound like an extraordinary leap in speed, it still wouldn't get us there in a human lifetime. And these numbers are just for the nearest stars. If we're talking about stars that are 100 light-years away, traveling at 10% of light speed, the journey would take 10,000 years. That's far beyond the lifespan of any civilization, and it puts into perspective just how big the distances between stars truly are. Now, let's explore the energy required to reach such speeds. The faster you go, the more energy you need to propel your spacecraft. And this energy demand increases exponentially as you approach the speed of light. In other words, as you try to go faster, it becomes exponentially more difficult to continue accelerating. To understand this better, let's take a modest example. Suppose we want to accelerate a 1,000 kilogram probe, roughly the size of a small car, to 10% of light speed. The energy required to accelerate this tiny probe to that speed is an unfathomable 450 quadrillion joules. To put that into perspective, a large nuclear power plant produces about 1 gigawatt of continuous power. This means that 1 gigawatt is equal to 1 billion joules per second. Stay. If we run that power plant at full capacity for an entire year, it will produce approximately 31.5 terajoules. To accelerate our 1,000 kilogram probe to 10% of light speed, we would need 14 years of the full output of a nuclear power plant. And this is just for one small robotic probe. No crew, no life support, just an object moving through space. Now, imagine scaling this up for a crew or a larger spacecraft. As the size and complexity of the spacecraft increase, so does the energy required. The energy needed to accelerate any spacecraft to even a fraction of light speed is simply astronomical. When we talk about fuel for space travel, we need to understand a critical limitation known as the rocket equation, first proposed in the early 20th century. This equation shows the relationship between the speed of a rocket, its fuel, and the mass it has to carry. The problem lies in the fact that to go faster, you need more fuel. But the more fuel you carry, the heavier your spacecraft becomes, and the more fuel you need to accelerate that extra mass. This creates a feedback loop where you need exponentially more fuel to achieve each incremental increase in speed. In simpler terms, the faster you want to go, the more fuel you need to carry. But if you're carrying more fuel, that means you'll need even more fuel to move that extra weight. This loop grows out of control very quickly. It's like trying to push a boulder up a hill. The more fuel you add, the more you need to keep adding. Even the most advanced propulsion systems we can imagine, like nuclear rockets, fusion engines, or antimatter propulsion, don't escape this fundamental problem. They all suffer from the same exponential increase in fuel requirements as speed increases. Let's take a step back and consider just how much fuel you would need to accelerate a small spacecraft to a significant fraction of light speed. For example, to travel at 10% of light speed, we would need to carry far more fuel than the total mass of the spacecraft itself. This isn't just a matter of improving existing rockets. It's a fundamental problem with the physics of motion. Even with nuclear-powered propulsion, which is vastly more efficient than chemical rockets, the amount of fuel required to achieve even modest speeds becomes an insurmountable barrier. Let's say we use fusion propulsion. This is seen as one of the most promising future propulsion technologies. With fusion, we could achieve speeds of up to 5% of light speed. This would be a significant breakthrough for interstellar missions. However, even with fusion propulsion, we would still need an immense amount of fuel to sustain such a journey. As we approach higher speeds, another problem emerges. According to special relativity, as an object accelerates toward the speed of light, its effective mass increases. This is not just a theory, it's a fundamental physical reality. The faster you go, the more mass you have, which means you need even more energy to keep going. At 99% of the speed of light, a spacecraft's mass would be 7 times greater than its original mass. At 99.9% of light speed, it would be 22 times heavier. This means that achieving even a modest fraction of light speed requires more energy than we can currently conceive of. And even though we can imagine faster spacecraft or better propulsion technologies, there's a hard limit imposed by the laws of physics. This isn't just an engineering challenge, it's a fundamental barrier. No matter how advanced our technology becomes, the energy requirements to achieve relativistic speeds will always grow exponentially. It's a wall that technology can't overcome. And it's not just about fuel or technology. It's about the geometry of the universe, the way mass, energy, and speed interact, and the way space itself resists our attempts to move through it. Now that we've explored the vast distances and insurmountable energy challenges involved in interstellar travel, let's move on to another crucial barrier that makes it almost impossible for aliens to reach Earth: communication. Even if an alien civilization were to somehow overcome the distance and energy hurdles, the problem of detecting Earth from across the vastness of space presents another impossible challenge. In this section, we will explore the limits of communication, the weak signals we emit, and why even the most advanced civilizations would struggle to find us, let alone make contact. Consider Earth from a distant star system, let's say 1,000 light-years away. To an alien civilization, Earth is a tiny speck orbiting an ordinary star in the far corner of the galaxy. Even if that civilization had the most advanced telescopes in existence, how would they ever detect Earth? The first problem lies in the sheer size of Earth. Our planet is tiny compared to the vastness of the space around us. Earth's diameter is about 8,000 miles. In the grand scale of the universe, it's practically invisible. From a distance of just a few light years, our planet would be invisible to even the best telescopes, and the faint glow it gives off is almost undetectable. Earth's reflected sunlight is not much brighter than a faint glow in the dark, and from 1,000 light-years away, the faint signals we produce are likely lost in the noise of other celestial bodies, stars, nebulae, and other cosmic phenomena. Our planet would be just another point of light, a dot among billions, lost in the infinite void of space. Let's look at another potential way aliens might detect us: radio signals. Humans have been sending radio waves into space for more than a century. These signals, though not very powerful, have been gradually expanding outward as they travel at the speed of light. But here's the thing: radio signals weaken with distance, and as they travel farther from Earth, they become harder and harder to detect. If we think about our radio emissions, the signals we've been sending since the early 20th century, they form a radio bubble that's about 200 light-years in diameter. That's a relatively small area of space, considering that the Milky Way galaxy alone spans 100,000 light-years. This radio bubble covers only a tiny fraction of the galaxy, less than 1/1,000,000th of its total volume. Any civilization more than 200 light-years away would be completely unaware of Earth's existence because our radio signals would be too weak to detect. Even worse, the inverse square law means that the strength of a radio signal diminishes with the square of the distance it travels. As our signals move farther out into space, if they get diluted and weaker, making them virtually indistinguishable from the cosmic background noise, the natural radio emissions of stars, pulsars, and other celestial objects. But let's assume that an alien civilization has technology so advanced that they can detect spectral signatures, the faint clues of chemical composition in the atmosphere of a distant planet. Could they detect Earth's oxygen-rich atmosphere, which is one of the most significant signs of biological activity? It's possible, but it's incredibly difficult. Earth's oxygen signature is faint, especially when you consider the vast distances between stars. The amount of light that reaches us from our Sun is diluted by the time it travels across the interstellar void. To detect the tiny fluctuations caused by Earth's atmosphere would require incredibly sensitive instruments. Instruments that could identify just a sliver of the light that Earth reflects, among the many other signals filling space. Even with the best telescopes and detection systems, the alien civilization would need to pinpoint Earth's faint atmospheric signals from millions of other potential candidates in the galaxy. There are likely thousands of Earth-like planets in the Milky Way that may have atmospheres resembling ours. So isolating one planet's signature becomes even more difficult. Now, let's talk about the limits of telescopes. A telescope is a tool for gathering light. So it seems logical that aliens could use one to find us. But there's a major limitation. To see Earth from 1,000 light-years away, aliens would need a telescope with an aperture hundreds of kilometers across. That's right, hundreds of kilometers. This is orders of magnitude beyond the capabilities of any telescope humans have ever built, and far beyond what any civilization could realistically construct. Even with advanced technology, the resolution required to see Earth's tiny size at such distances simply isn't achievable. You can imagine an alien civilization using thousands of smaller telescopes working in concert to gather light from distant stars. But even with such an array, Earth would remain too small to resolve, let alone detect life. Even if an alien civilization detected Earth, how would they communicate with us? Let's imagine that they sent out a message using a powerful radio signal, hoping to make contact with us. The challenge they face is that light-speed communication takes time, and that time is measured in centuries, even millennia. If an alien civilization sends a message to Earth, it would take several years for the message to arrive. Then we would need several years to respond. In a situation like this, every message becomes a message in a bottle, lost at sea, with a vast time delay making it practically impossible for meaningful communication to happen. A single exchange of information, like a question and a response, could take centuries. And the longer the distance, the worse it gets. For instance, a message sent from 1,000 light-years away would take 1,000 years to reach us. By the time we received it, the civilization that sent it might have already moved on, collapsed, or disappeared entirely. The conversation would become an endless cycle of waiting, guessing, and miscommunication. Even if an alien civilization could detect Earth, it would be operating on timescales that are completely incompatible with the life of the civilization that sent the message. Imagine an alien civilization that sends a probe or a message to Earth, hoping for a response. The problem is that humans don't have centuries to wait for a reply. We move on too quickly. Technologies change, civilizations evolve, and the people who would originally send a message to an alien world could be long gone by the time their message reaches us. In short, the communication barrier is just as daunting as the distance barrier. Even if aliens knew where to look and could see us, the time it would take to reach us and the communication lag would render meaningful contact all but impossible. Now that we've covered the vast distances, energy requirements, and communication challenges, there's yet another insurmountable barrier to interstellar travel and contact: time. In this section, we'll explore how the relentless passage of time affects not only the journey itself, but also the alien civilizations that might attempt to reach us. Time is a universal force, and it doesn't just affect travel. It impacts the very existence of any mission or civilization that attempts to travel across the stars. Let's dive into how time introduces a new set of problems. Imagine an alien civilization decides to send a probe or a spaceship from their star system to Earth. Let's assume they have the technology to travel at 10% of the speed of light, a significant leap from current capabilities. At this speed, it would take them about 730 years to reach Alpha Centauri, the closest star to Earth. That's already far beyond a human lifetime, which means no single generation of aliens could ever embark on such a journey and return. Even with advanced technology, a single mission to a nearby star would take centuries, and by the time the probe arrived, it would be a legacy of a past civilization. For an alien mission to Earth, the journey time alone is already an issue, and the problem only magnifies when we start talking about more distant stars. If a star is 100 light-years away, traveling at 10% of light speed, it would take 10,000 years to get there. A star 1,000 light-years away. That's 100,000 years of travel. Human civilization has only existed for about 12,000 years, and the oldest known civilizations, like those in Mesopotamia and Egypt, are a fraction of that age. So for an alien civilization to launch a mission to a distant star, they would need to commit to a project that spans generations, maybe even millennia. If no single generation can survive a journey of thousands of years, what about generational ships? A generational ship is a theoretical spacecraft designed to carry a population that would live and reproduce aboard the ship during the journey. The idea is that as one generation of travelers dies off, another would be born, continuing the mission across the centuries. At first glance, this might seem like a potential solution, but the practical realities of such a mission are overwhelming. Let's consider the biological challenges. A generational ship would need to house a population large enough to avoid genetic problems like inbreeding. Studies suggest that a minimum of 5,000 to 10,000 people would be necessary for long-term genetic health. Maintaining a viable closed ecosystem is another massive hurdle. Every resource, air, food, water, must be recycled and sustained indefinitely. This isn't something that has ever been achieved on Earth for longer than a few years, and the scale required for a generational ship is orders of magnitude greater than anything we've attempted. The ship itself would need to be self-sustaining for thousands of years, with no chance of resupply or outside assistance. This would require a level of engineering and resource management that is beyond anything we've ever conceived. In addition to the biological challenges, the social problems aboard a generational ship would be equally disastrous. Societies change over time, and the culture that launches the mission would likely dissolve or transform over millennia. Ideological shifts, revolutions, and cultural evolution would transform the mission's original purpose. The people aboard would lose connection with the mission's original goal as time passed. In 500 years, the mission's goal might not even be relevant anymore, and psychological issues would become a critical problem. Imagine living for generations in a sealed metal capsule, without any possibility of seeing the sky or experiencing nature. The mental health of the passengers would deteriorate over time, especially with no escape, no horizon, and no new ideas. The practical issues of a generational ship are so overwhelming that even the best engineers in the world today would find it almost impossible to design such a craft that could survive the millennia required to reach even the nearest star systems. One of the most devastating problems with long-term space missions is the issue of technological obsolescence. The civilization that launches the mission may not survive the journey. As technology advances at an exponential rate, mission-critical equipment would become obsolete before it even arrives. Let's say an alien civilization launches a spacecraft to Earth, sending it on a journey to reach us in 10,000 years. The technology they use will undoubtedly be outdated by the time the mission reaches its destination. Even with the most advanced propulsion systems, and they will face an increasingly difficult problem. The systems they've built will break down and be impossible to repair. As time passes, the spacecraft will become more and more like a fossil, an ancient relic of a civilization that has either disappeared or evolved beyond recognition. This technological obsolescence isn't just a small issue, it's the ultimate failure for any long-term space mission. The tools, systems, and knowledge required to maintain the spacecraft would vanish over time, and the mission would be doomed to fail long before it reached its goal. We've already seen that time plays a crucial role in interstellar travel. But the way civilizations evolve over time adds an even greater layer of difficulty. Think of it this way. Human history spans only 12,000 years, and already we've seen massive changes in our societies, technologies, and governments. In the future, human civilization might not look anything like it does now. In fact, it's likely that the civilization that launches a space probe will change or dissolve long before the probe arrives at its destination. For any civilization attempting long-distance space travel, the passage of time introduces a paradox. The longer they wait, the more advanced their technology becomes. But by waiting for better technology, they may never launch at all. If they launch prematurely, the technology will become obsolete by the time the spacecraft arrives. This circular problem makes interstellar travel not just a technical challenge, but a philosophical one. A civilization might be aware of the need to explore, but will they be able to maintain the drive over thousands of years of waiting, evolving, and changing? Now that we've explored how time affects both space travel and communication, let's examine how civilizations themselves face challenges that are tied to the passage of time. Interstellar travel isn't just about a journey, it's about the long-term survival of a mission and the civilization that launches it. One of the most talked about solutions to the problem of interstellar travel is the idea of a generational ship, a spacecraft that carries a population over many generations. The concept is simple. A group of travelers departs from Earth and lives aboard the ship, and their descendants continue the mission after they die. While this might seem like a feasible solution, there are massive biological and social problems that make generational ships virtually impossible. Biological issues. For a generational ship to survive, it would need to maintain a genetically viable population over hundreds or even thousands of years. To avoid the dangers of inbreeding, the population would need to be in the thousands, potentially 5,000 to 10,000 individuals. But ensuring the long-term health of such a population aboard a spaceship in deep space without access to external resources is a monumental task. Even with the best life support systems in place, a generational ship would have to manage reproduction, genetic diversity, and health over many generations. There's also the ecosystem problem. The the spaceship would need a fully closed-loop environment, where everything from food to water is recycled without outside input. Maintaining such an ecosystem over thousands of years is a challenge that we haven't come close to solving. Even with all the modern technologies at our disposal, a completely self-sustaining system has never been achieved for long periods, and the scale required for interstellar travel is unimaginable. Social issues. Over time, the social structure aboard the ship would deteriorate. Generations would be born and die on board. And over centuries, the cultural mission that started the journey would be lost or distorted. What happens to the original mission when the original crew has passed away, and their descendants no longer remember why they started the journey in the first place? With each passing generation, the purpose of the mission would likely shift, leading to inevitable cultural fragmentation. Social pressures in such a confined space could lead to psychological challenges as well. Humans need connection with the outside world, the sky, nature, and a sense of freedom. A generational ship would be like a cage, a sealed metal box orbiting distant stars with no horizon or escape. The mental health of travelers would eventually break down, leading to potential psychological crises and social conflicts. We can see this happening even in small-scale experiments such as Biosphere 2, where a tiny team struggled to survive in a confined ecosystem for only 2 years. Even if we solve the biological and social issues aboard a generational ship, there's another critical problem. The technology used to launch the mission would inevitably become obsolete before the journey is complete. This is the problem of technological obsolescence. The advancement of technology doesn't stop just because a spacecraft launches into the cosmos. A spacecraft might leave Earth with the best technology available, but over centuries, new technologies would be developed. By the time the spaceship arrives at its destination, it could be using outdated systems that no longer function. Even with the most advanced engineering, the systems on board would eventually break down or become incompatible with newer technologies. The energy requirements and maintenance needs of the spacecraft would only become more difficult over time. Systems would wear out and parts would become impossible to replace. There's no resupply when you're in deep space, no repair shops to turn to, and no external help when things go wrong. The technology on board would eventually become a relic of a civilization long gone, drifting through space with no hope of repair. As the technology of the spacecraft becomes outdated, so too does the original purpose of the mission. The civilization that sent the spacecraft on its journey may no longer exist. Over centuries, societies evolve, governments fall, and new civilizations emerge. The alien civilization that launched the spacecraft might have undergone significant changes during the course of the journey. By the time the spacecraft reaches Earth, the mission could be seen as irrelevant or obsolete. The values and goals that motivated the mission might be entirely forgotten by the time the spacecraft arrives at its destination. The alien civilization that launched the mission could be gone entirely, and the descendants of those who initiated the journey might not even care about the mission anymore. This is not just a problem for alien civilizations. It's a problem for us as well. Imagine if we launched a space mission to another star, only to realize that in 1,000 years, human civilization has changed so drastically that the mission is no longer relevant, or that the technology used to send the spacecraft is obsolete and unfixable. The most critical issue of all is that time, unlike distance or energy, is relentless. The passage of time doesn't stop for any civilization. The mission that is launched today might have been a top priority for its creators, but by the time it reaches its destination, everything could have changed. The civilization that launched the mission may have evolved into something entirely different, or it may have collapsed entirely, leaving behind only the legacy of a project that no one cares about anymore. Even if they reach Earth, the message they bring may be lost in the void of space, out of sync with the civilization they intended to reach. Imagine an alien civilization that sends a probe or a generation ship to Earth, only to have the civilization that launched it be long gone by the time it arrives. The descendants of that civilization might have abandoned the project, or the technology may have become so outdated that it's no longer viable. This is the inevitable fate of every long-term mission. As we move further into the concept of interstellar travel, there is one more insurmountable barrier to consider: the energy wall. Even if alien civilizations could overcome the vast distances and the overwhelming challenges of time, there is still one significant force that no technology, no matter how advanced, can overcome. The energy requirements for interstellar travel are simply beyond anything imaginable. To even begin to approach the speed of light, let alone reach distant stars, would demand a level of energy that no civilization, even one far more advanced than ours, could harness. The most optimistic projections suggest that we could one day build spacecraft capable of traveling to distant stars, but those projections hinge on one major assumption: that we can somehow solve the energy crisis of deep space travel. At our current level of technology, launching a small spacecraft into low Earth orbit requires massive amounts of energy. We rely on rocket propulsion systems, which burn through enormous amounts of fuel in the process. Now, imagine applying that same concept to interstellar travel. Only we are talking about the need to propel a spacecraft over hundreds of trillions of miles. The scale of energy required to sustain such a mission is so large that it transcends the capabilities of any known propulsion system. Even with the most advanced nuclear propulsion technology, the energy needed would be incomprehensible. Take, for instance, the concept of fusion propulsion, which is often cited as a potential solution. Fusion, the same process that powers stars, could theoretically provide the immense energy needed to propel a spacecraft across the stars. However, while fusion might be an effective energy source in the far future, we still have no reliable method of controlling and harnessing fusion energy in a way that could power a spacecraft over long durations. Or even if we managed to create such a system, the sheer amount of energy required to accelerate a spacecraft to even a fraction of the speed of light would mean that fuel, no matter how efficient, would quickly run out. The fuel-to-mass ratio, which is already a challenge with current technologies, would only become more problematic as the spacecraft's velocity increased. Moreover, it's not just about having the energy to move the spacecraft. Every single part of the journey would require continuous energy input. The life support systems for any crew would need to run without fail for the duration of the mission. The spacecraft would need constant energy to maintain habitation conditions, to produce enough food, to recycle water, and to maintain all the communications with home. Assuming that home is still there after hundreds or thousands of years, the demands of deep space survival are so staggering that even the most energy-efficient systems would eventually fail under the weight of the task. Perhaps the most fundamental issue is the speed at which we would need to travel. Even a small fraction of the speed of light, say 1%, would require exponentially more energy than we can currently conceive. As we accelerate closer to the speed of light, the energy demands increase at a rate that approaches infinity. At 10% of the speed of light, a spacecraft would need enough energy to generate an enormous amount of thrust, enough to move a mass of even just a few tons across the vast emptiness of space. But this doesn't account for the deceleration phase, which is also incredibly energy-intensive. To slow down after traveling across the stars would require as much energy as it took to accelerate in the first place. This energy dilemma puts a hard cap on the feasibility of interstellar travel. Even if a civilization had access to extraordinary resources, such as harnessing the power of entire stars through a Dyson sphere, a hypothetical structure that could capture the entire energy output of a star, they would still face an energy ceiling that simply cannot be surpassed. The laws of physics don't change based on technological prowess, and no matter how advanced a civilization becomes, they will always encounter the same energy bottleneck that keeps them tethered to their home planet, unable to venture beyond their stellar neighborhood. Even with an energy source as powerful as a Dyson sphere, there's another problem to consider: the vast scale of resources required for such a structure. To build a Dyson sphere would require trillions of tons of material and the collective effort of billions of years. A civilization would need to first harvest and process unimaginable quantities of resources from their solar system before they could even begin building a structure that could allow them to travel the stars. The energy required for construction would also be beyond comprehension. Even if we could theoretically mine the entire mass of planets, asteroids, and moons in our solar system, the logistics and scale of the endeavor would stretch any civilization's capabilities to their absolute limits. While we can dream of traveling to distant stars and exploring alien worlds, the energy required to make such journeys possible is a barrier that no amount of technological innovation or ingenuity can currently overcome. Until a civilization can figure out how to tap into the fabric of space itself, perhaps through something like warp drives or other forms of exotic propulsion, we are left with the cold, hard reality that interstellar travel is likely out of our reach. It's not about the will to explore the stars. It's about the energy it would take to make that exploration possible. And for now, that energy is far beyond our grasp. The energy barrier isn't the only obstacle preventing interstellar travel. The very structure of the universe itself presents an insurmountable challenge for any civilization trying to reach another. It's not just the immense distances or the overwhelming energy requirements. It's also the cosmic isolation that is woven into the fabric of space. The universe is vast, and not only are the stars far apart, but the galaxies themselves are spreading away from each other, making it increasingly unlikely that civilizations will ever be able to come together. This cosmic isolation is driven by the expansion of the universe. Since the Big Bang, the universe has been expanding, and while this expansion initially happened at a slower rate, it has accelerated dramatically due to what we now call dark energy. Dark energy is an unknown force that is pushing galaxies further and further apart at an accelerating pace. As this expansion continues, the distances between galaxies grow so rapidly that even light itself has difficulty keeping up. In other words, the very space between objects in the universe is stretching, pulling galaxies farther apart. As the expansion of the universe continues, stars in faraway galaxies will eventually recede from our observable universe altogether, meaning that even light from those galaxies will never reach us. It's as though we are trapped in our own small bubble of space, surrounded by an ever-growing emptiness. Any alien civilizations that might exist in galaxies that are on the other side of the universe's expansion will become invisible to us, and we, in turn, will become invisible to them. This growing isolation is not just a matter of perspective. It has real consequences for the future of any interstellar exploration efforts. Imagine a civilization that reaches a point where it has perfected space travel and developed the means to explore the stars. But when they look out across the cosmos, they find that the galaxies they would want to visit are drifting away faster than they can travel. The expansion of the universe renders travel between galaxies virtually impossible. In this sense, the more we learn about the universe, the more we realize that we are not just separated by space, we are separated by time as well. As galaxies move farther apart, the cosmic horizon becomes more and more distant, meaning that we will never be able to reach or even detect the galaxies that are receding from us. In a few billion years, when the universe has expanded even further, it is likely that only our local group of galaxies will be within reach. Everything else will be beyond the cosmic horizon, lost to time and space forever. Even if alien civilizations are out there, separated by these incredible distances, they are more likely to remain isolated from us, not because we can't find them, but because the universe itself is isolating us from one another. This cosmic isolation is a sobering thought. Even with the most powerful technology, a civilization may not be able to overcome the physical limitations imposed by the universe. It's not just that we haven't found aliens yet. It's that the universe may be inherently designed to keep us apart. The cosmic expansion ensures that even if civilizations do exist in other parts of the universe, they will be unable to reach us or communicate with us. This cosmic isolation is perhaps the most crushing barrier to interstellar travel and communication, as it operates on a scale far beyond anything we could ever hope to overcome. The reality is that no matter how far humanity advances, the universe remains a vast, unbridgeable chasm. It is difficult to imagine how any civilization could remain cohesive and sustainable over the vast time spans required for interstellar exploration. The resources, energy, and technology required to cross the immense distances between stars are beyond our comprehension. And even if we somehow manage to travel to distant worlds, the cosmic isolation means that we would likely remain alone, with no other civilizations to share our discoveries or to make contact with. This isolation is not limited to the space between stars. It extends to the time between civilizations. Civilizations rise and fall, often before they have a chance to make contact with other intelligent beings. Even if alien civilizations exist, they may have already risen and fallen long before we even had the technology to detect them. The distance between stars, the energy required to travel, and the ongoing expansion of the universe create a unique paradox. While civilizations may emerge, they are often too far apart in both space and time to ever meet or communicate. This paradox of cosmic isolation reminds us that we are not just small in terms of physical distance, we are small in terms of time as well. The cosmic clock ticks on, with civilizations born and dying before they have the chance to connect with one another. The window of opportunity for making contact with other civilizations is narrow, and it is likely that even if other civilizations exist, they too are living in a universe that has rendered them isolated, separated by time and space. The more we understand about the universe, the more we realize how little we know about our place within it. The overwhelming distances between stars, the limits of energy, and the relentless march of time make interstellar exploration seem not just difficult, but impossible. It's a humbling thought. We may be living in a universe teeming with potential, but the barriers to reaching out and connecting are so immense that it seems likely we'll remain forever alone in the vast, dark expanse of space. As we explore the impossibility of interstellar travel and communication, we must confront the fundamental issue that all of this hinges on: human civilization itself. The idea of sending humans to distant stars, or even sending robotic probes that could successfully complete such missions, is inextricably tied to the survival of our own society. A civilization capable of interstellar exploration must first survive the trials of time, energy, and resources here on Earth. The obstacles we face are not only external, they are internal. One of the first and most difficult challenges is the social and political stability required to sustain such an endeavor. Undertaking interstellar travel is no small feat. It requires cooperation on an unimaginable scale, both in terms of resources and human effort. In our current political climate, with nations often struggling to cooperate on even regional issues, the idea of a global society working together for a shared interstellar mission seems not just improbable but nearly impossible. Even if we set aside the incredible technical and physical hurdles, the reality is that civilizations, as they exist now, are fractured by differences in culture, ideology, and geopolitics. For interstellar travel to become feasible, a level of global unity would be required. One where political barriers, resource scarcity, and social divisions no longer stand in the way of collective action. But achieving this kind of unity on Earth, especially over long time frames, is a monumental task. The potential for conflict, resource competition, and societal collapse is always present. And these are the very factors that could doom any large-scale mission. It's important to realize that a civilization that would seek to travel to the stars is a civilization that would need to have conquered its own internal conflicts. And yet, even if we manage to overcome these societal barriers, the technological issues are even more daunting. The machines and systems required to send humans or probes across the stars would need to be long-lasting, self-sustaining, and capable of operating autonomously for thousands of years. Consider the fate of Voyager 1, which has been traveling through space for over 40 years. Yet it is already facing the limits of its power supply and will soon be unable to communicate with Earth. Now, imagine a spacecraft that must last for thousands of years, operating without human oversight, without any kind of repair or maintenance in the harsh, uninhabitable environment of deep space. Even with advanced self-repair technologies, or AI, the challenges of maintaining a spacecraft over such immense spans of time are staggering. The failure of even the most advanced system on Earth, such as the International Space Station or long-term lunar missions, highlights just how difficult it is to maintain technology beyond our immediate environment. In the vacuum of space, with cosmic radiation constantly bombarding everything, the wear and tear on spacecraft systems would be tremendous. There are simply too many unknowns in the process of sending a ship across the stars that could render it obsolete before it even arrives at its destination. This is especially true for missions that would last hundreds or thousands of years. No technology we currently possess is capable of lasting that long in such an unforgiving environment. But beyond the technical and political obstacles, perhaps the most significant challenge is the psychological toll of interstellar travel. Long-term space missions, even those that last only a few years, already put a strain on the mental health of astronauts. The isolation, the confinement, and the constant pressure of living in a small artificial environment take their toll on even the most resilient individuals. Imagine a spacecraft that must house its crew for generations, cut off from Earth, with no prospect of return, and with no way of sustaining meaningful communication with their home planet. The mental health of those aboard would be the largest unknown factor in the success of such a mission. How would humans cope with the loneliness, the uncertainty, and the realization that their entire existence might be spent in transit to a world they may never see? The psychological effects of long-term space travel are already being studied in the context of the Mars missions, where astronauts would spend up to a year or more in isolation from Earth. Yet, a journey to the stars would last much longer, likely many generations. Even the most advanced technology we have for supporting life in space is not enough to guarantee that those aboard would be able to maintain their mental health over such long stretches of time. What happens when generations of crew members are born and die in space, with no hope of ever returning to Earth or seeing their families again? And then there's the issue of space radiation, a relentless and dangerous force that could potentially wipe out any crew long before they ever reach their destination. We are only just beginning to understand the effects of space radiation on human health, but it's already clear that prolonged exposure to cosmic rays and solar radiation has a devastating impact on human bodies. The farther we venture into space, the more radiation we encounter, and the more dangerous it becomes. Even with the best shielding, a spacecraft's inhabitants will be subjected to long-term exposure to this radiation, leading to genetic mutations, cancer, and other devastating health issues. No matter how advanced our space technology becomes, we are still left with the reality that space is an inherently hostile environment for human life. The isolation, the lack of resources, the breakdown of systems, and the continuous assault of space's harsh conditions. All of these challenges combine to make interstellar travel an almost impossible task. It's not just about reaching the stars. It's about surviving the journey, maintaining a civilization, and ensuring that the humans aboard are able to sustain themselves mentally, physically, and technologically for the duration of the voyage. Even if an alien civilization could overcome these challenges, it's likely they would have already faced their own version of these insurmountable hurdles. Perhaps their civilizations collapsed before they could ever send a ship into the stars. Perhaps they reached a point of technological sophistication, but realized that the cost of such an endeavor was far too high to be worth the effort. In any case, the fate of interstellar travel remains the same. It's a theoretical dream, but one that, for now, remains just that, a dream. The overwhelming truth that emerges as we consider the impossibility of interstellar travel is that no matter how much technology we develop or how advanced our civilization becomes, there will always be an insurmountable wall preventing us from reaching the stars. The universe, in its vastness, is inherently isolating. And this isolation is not just a physical barrier, but a temporal one as well. The relentless passage of time ensures that the idea of interstellar travel is ultimately unachievable. As we've discussed, the distances between stars are so immense that even with the fastest propulsion systems, a spacecraft would take thousands of years to reach the nearest star. This presents a challenge not only for current technology, but for future generations. A civilization that launches an interstellar mission today may no longer exist by the time the spacecraft reaches its destination. The time it would take for such a mission to succeed is so long that the technological infrastructure that launched it would disintegrate before the journey is complete. In many ways, the problem of interstellar travel is a reflection of the nature of time itself. Time moves forward relentlessly, and civilizations rise and fall, often within a blink of the cosmic eye. Even if a civilization were to establish the technology required for interstellar travel, it would face the fact that by the time it reaches the stars, that same civilization may have evolved, collapsed, or vanished entirely. The very effort to explore the stars could be doomed by the passing of time, as the civilization that begins the journey might not be the same one that completes it. This isn't just a problem for humans. It's likely a universal dilemma. Alien civilizations, if they exist, are likely facing the same constraints. They may have developed advanced technologies, but the vast distances between stars and the long durations required for such missions would mean that their endeavors, too, would be interrupted by the passage of time. The likelihood that any civilization could both develop the necessary technology and survive long enough to send a mission to distant stars is extremely low. Beyond the physical constraints of space and time, the psychological burden of such an endeavor is immense. A civilization would need to be prepared to maintain its mission over an unfathomably long period. This isn't just a matter of keeping the spacecraft running. It's about keeping the dream alive over generations of people, many of whom would never see the goal of the mission. Imagine the mental toll it would take on those aboard a generational ship, traveling to a distant star knowing that they or their descendants would never see the destination. The mission would become less about exploration and more about survival. A constant struggle to maintain a sense of purpose in the face of a journey that seems endless and, at times, hopeless. And even when we consider the possibility of artificial intelligence or autonomous spacecraft, and the same problems persist. A machine can't continue forever if its power source fails, its systems degrade, or its resources run out. No matter how advanced AI becomes, the problem of maintaining a spacecraft over millennia is still unsolvable. The longer the journey, the more likely the spacecraft will become a derelict, adrift in the cold void of space, its mission lost to time. Ultimately, this leads us to the hard truth. The very nature of the universe, with its immense distances, harsh conditions, and the endless progression of time, ensures that interstellar travel is not just a matter of technology or ambition. It's a concept that cannot be realized due to the inherent limitations built into the fabric of reality. The distances are too great, the energy demands too high, and the timescales too long. No matter how much technology advances, no civilization, no matter how advanced, can ever truly conquer the impossible expanse of space. As the universe expands, as stars fade and new ones are born, the possibility of contact or connection between civilizations seems more and more remote. The cosmic isolation that once seemed like a mere inconvenience becomes an intractable reality, a force that keeps all civilizations within their own isolated bubbles, unable to reach or even detect one another. And even if there are other civilizations out there, the immense distances and the finite lifetimes of civilizations mean that we may never meet or communicate with them. The very expansion of the universe ensures that, over time, we are becoming more and more separated from any other potential life forms. The cosmic isolation is not a choice, nor is it a temporary state. It's a fundamental feature of the universe, one that no technology or advancement can escape. The universe itself is expanding too quickly, and as it does, it drives civilizations further apart, locking them into their own isolated corners of the cosmos. We may look up at the stars and dream of distant worlds, but the truth is, the universe may be designed to keep us alone. The distance, the energy, the time, all of these factors ensure that interstellar travel, no matter how desperately we wish for it, remains impossible. The universe keeps its secrets locked away, and the dream of exploring the stars may always remain just that, a dream, forever out of reach. Despite the many theoretical advancements in technology, propulsion systems, and energy sources, the harsh reality remains. The structure of the universe itself actively works against the possibility of interstellar travel. The concept of the unreachable alien isn't just a metaphor, it's a fundamental truth driven by the very nature of space and time. Even if alien civilizations exist, they are likely isolated from us, just as we are isolated from them. The universe is constantly expanding, and the rate at which galaxies move away from each other has been increasing since the Big Bang. This expansion means that distant galaxies and stars, even if they harbored intelligent life, are moving away from us at speeds faster than light, due to the stretching of space itself. As space expands, cosmic horizons are pushed further away, and regions of the universe that once may have been reachable are now completely inaccessible. This phenomenon known as the accelerating expansion of the universe, essentially locks alien civilizations within their own isolated pockets of space, making any contact between civilizations incredibly unlikely. While we can imagine the possibilities of alien civilizations out there, trying to make contact with us, the expanding universe creates an insurmountable barrier that makes any form of communication or travel across intergalactic distances virtually impossible. As galaxies drift further and further apart, we are becoming increasingly isolated, not just by distance, but by the very fabric of the universe itself. The vast stretches of space that separate us from any potential alien life forms will only grow larger with time, and the more time passes, the less likely it becomes that we will ever make contact with another civilization. Even if an alien civilization somehow develops the means to travel across interstellar space, they would still face the inevitable barrier of time. The time it takes to cross vast distances would mean that the technological systems required for such a journey would likely break down long before they ever reach their destination. As we've seen with humanity's own space probes, even the most advanced technologies we have today, such as Voyager 1, will eventually run out of power and be unable to continue their journey. A probe launched today could reach a distant star system, but by the time it arrives, it would be nothing more than a fossil of the civilization that launched it, incapable of performing any meaningful task. The breakdown of technology over time, combined with the relentless march of time, ensures that even if we could somehow reach distant stars, the mission itself would be doomed to failure due to the collapse of the necessary technology. The psychological toll on any civilization attempting such a journey would also be immense. Generational missions that span thousands of years would require an incredible amount of resilience and mental fortitude. The journey itself would take place over a time scale so long that the original mission could become irrelevant, and the technology used to launch it would be obsolete long before it reached its destination. Even if a civilization could overcome the energy and distance barriers, the mental strain of maintaining a mission over millennia would likely cause it to fall apart. Long-term isolation in deep space with no possibility of return would be a psychological nightmare for any crew, leading to potential breakdowns in both society and technology. Perhaps the most sobering thought is the idea that even if other civilizations exist, the distance between us and them, compounded by the expansion of the universe and the time it takes for communication, means that we may never meet. Alien civilizations, if they exist, may be as far out of reach as the stars themselves. And even if we somehow manage to detect signs of intelligent life elsewhere, it could be too late. By the time we receive their signals, their civilizations could have already fallen or evolved into something entirely unrecognizable. In the end, the dream of interstellar travel may be a beautiful idea. But it is an idea constrained by the very laws of nature. The universe is too vast, the distances too great, and time too unforgiving for any civilization, human or alien, to bridge the gap. Even if alien civilizations exist, they are likely facing the same barriers we are, isolated in their own corners of the universe, just as we are. And as the universe continues to expand, the chances of ever meeting another civilization dwindle with each passing year, leaving us alone in the vastness of space, cut off from the rest of the cosmos. As we look further into the distant future, we are faced with the inescapable reality that the very nature of the universe may prevent any lasting connection between civilizations, whether human or alien. The expansion of space continues to push galaxies further away from one another, isolating us even further with each passing day. No matter how much we might want to dream of interstellar travel, the harsh reality is that the vast spatial and temporal gaps between stars and civilizations will forever keep us isolated. In the long run, this isolation may even become irreversible. Over billions of years, stars will burn out, galaxies will merge or drift away, and the universe will continue to cool and expand. In this future, Earth itself will become increasingly uninhabitable. The Sun, our life-giving star, will continue to evolve, gradually burning brighter and consuming more of our planet's resources. Over the next few billion years, it will exhaust its fuel and expand into a red giant, potentially swallowing Earth in the process. Even if humanity survives this transition, the long-term habitability of Earth will be compromised, pushing our species to find new homes in the distant corners of space. But the further we venture, the more we face the same cosmic barriers that have kept us isolated in the first place. The heat death of the universe, where stars run out of fuel and galaxies drift into an infinite void, is one potential fate for everything we know. This eventual cosmic end will leave behind a universe that is cold, dark, and empty, with only the faint traces of once vibrant civilizations scattered like dust across the emptiness of space. In this scenario, the dream of exploring the stars would be nothing more than a distant memory, a fleeting hope that fades with time. Even if we manage to build advanced spacefaring civilizations and explore other star systems, we must also contend with the inevitable decline of technological and social systems. History is filled with rise and fall, empires, civilizations, and cultures that once thrived and then crumbled under the weight of time, conflict, or resource depletion. The fate of humanity, or any civilization, may ultimately be the same. As we continue to push forward into space, we may encounter our own collapse in the face of environmental destruction, social unrest, or technological stagnation. The challenges of living on Earth are already pushing us to the brink, and no matter how far we venture into space, the fragility of civilization is a constant reminder of our limitations. However, even in the face of these cosmic barriers, humanity has an incredible capacity for adaptation and ingenuity. Our greatest hope for survival may lie not in traveling to the stars, but in learning to thrive within our own solar system, transforming barren planets like Mars into habitable worlds, or harnessing the power of astrophysical phenomena to propel us toward a sustainable future. As long as we can learn to adapt, to manage our resources, and to solve the deep-rooted challenges that threaten our survival, there may still be a way for humanity to continue its journey across the cosmos. Even if we never physically reach the stars, yet this dream of adaptation also faces a fundamental challenge. We are fighting against time itself. The solar system offers a finite window of habitability, and as our sun continues to evolve, we may only have a few billion years before Earth and its neighboring planets become inhospitable. The farther we go into the future, the more difficult it becomes to imagine that any civilization, ours or another, could survive in the long term, given the constraints of space, energy, and time. Perhaps the only way forward is to embrace a new philosophy of existence, one that doesn't rely on the impossibility of interstellar travel, but on the sustainability of life within the confines of our immediate environment. Instead of seeking to conquer the stars, we may need to focus on how to live harmoniously with the natural limits of the universe. As technology advances, we may find ways to extend the lifespan of our civilization, perhaps by developing technologies that can capture the energy of distant stars or colonize other planets within our own solar system. But even then, we will always be bound by the limitations of our solar neighborhood. The closest stars and galaxies will always remain far out of reach. And what of the alien civilizations that might exist out there? As we continue to search the skies for signs of extraterrestrial life, we may be forced to confront the reality that we are alone in a vast, expanding void. Even if other intelligent species have risen and fallen in the distant past, the expansion of the universe ensures that their signals, their legacy, will never reach us. The great silence that envelops the cosmos may not be the result of alien apathy, but of a universe that prevents us from ever meeting. The vastness of space, combined with the time dilation effects of distance and the expansion of space, means that the chances of any meaningful contact between civilizations are incredibly slim. Ultimately, the isolation of alien civilizations, and even our own, may be the defining feature of the universe. As stars burn out and galaxies drift apart, the cosmic expanse will only grow larger, more empty, and more inaccessible. The dream of traveling across the stars may be a beautiful one, but it is ultimately a dream that is out of reach for any civilization. As we look up at the stars and wonder if we are truly alone, we may eventually realize that the universe itself, in its vastness and complexity, has isolated us, not just from other civilizations, but from the very possibility of ever truly connecting with them. As we confront the unyielding barriers of space and time, we must also acknowledge the inevitable conclusion that, despite the potential for life elsewhere in the universe, the survival of humanity, and any civilization for that matter, is not guaranteed. The universe, in all its vastness, is a place of unrelenting change. Whether we talk about the end of the sun, the dissipation of energy, or the entropic march towards universal heat death, the universe is indifferent to the fate of any single species. And this isn't a distant, theoretical concern. It's a reality that we must face as we look into the future. The sun will eventually run out of fuel, transforming into a red giant, expanding beyond the Earth's orbit. While this may seem like an event that lies far in the future, around 5 billion years from now, the eventual fate of the sun is a reminder of how short-lived even our star is in the grand timeline of the universe. As the sun dies, Earth will become increasingly inhospitable. The temperature will rise to unbearable levels, and the oceans will evaporate into the atmosphere. It's not just a threat for humanity, it's a cosmic event that will affect every form of life on this planet, regardless of what we do to prepare. Humanity's time on Earth will come to an end long before the universe reaches its eventual heat death. Even if we manage to colonize other planets, terraform distant worlds, or build space habitats that allow us to survive beyond the Earth, we're still facing the fact that our time in the universe is limited. The cosmic clock is ticking, and no matter how much technology we develop or how far we extend our reach, the ultimate end is inescapable. In the vast scale of time, civilizations are but fleeting moments, emerging and falling into the abyss of history as quickly as they rise. No civilization is immune to this fact, not even one capable of building spacecraft to travel between the stars. Even if humanity survives the death of our solar system, the ultimate fate of the universe will continue to pose insurmountable challenges. The universe, according to current scientific understanding, is headed towards heat death. This state of universal entropy will occur when all energy sources have been exhausted, and the universe has reached a state of maximum disorder. The stars will burn out, the galaxies will drift apart, and the matter in the universe will become cold and dark. There will be no more stars, no more life, no more possibility of interstellar communication or travel. The universe will be a vast, silent expanse, devoid of the energy necessary to sustain life or any form of meaningful existence. In this cosmic future, it's difficult to imagine how any civilization, ours or anyone else's, could survive in such a hostile environment. As the universe expands and cools, it will become increasingly empty, with galaxies and stars drifting beyond our reach. The energy required for any form of life or activity will be impossible to sustain. It's a finality that even the most advanced civilizations may not be able to overcome. Whether they are human or alien, they will face the same eventuality: the death of the universe itself. Even if we were to discover ways of harnessing new forms of energy, such as extracting power from black holes or tapping into the quantum fabric of space itself, these technologies would be limited by the fundamental laws of thermodynamics. The universe, in its ultimate state, will reach a point where all useful energy is expended, and no matter how much we try to adapt or evolve, we would still be bound by these immutable laws. One might argue that our best hope lies in the development of artificial intelligence and the potential to upload human consciousness into machines. The idea that we could somehow upload our minds and continue existing in a digital or mechanical form. But even that possibility faces tremendous hurdles. The storage and processing power required to sustain even a single consciousness on a cosmic scale would be beyond our comprehension. How could we hope to preserve life or identity over millennia in a universe that is inherently hostile to any form of existence? The vast distances, the time decay, and the lack of resources make it unlikely that any form of digital immortality would survive the eventual entropy of the universe. In the end, no matter how much we strive to escape the confines of our solar system, the laws of nature will continue to constrain us. Whether through the limits of time, the increasing isolation caused by the expansion of the universe, or the inevitable decay of the cosmos, we will eventually find that our survival in the universe is not guaranteed. We may explore the stars, reach out to alien civilizations, and develop technologies that seem impossible today. But we will always face the crushing reality of the finite nature of existence. The universe may be vast, but it is also finite. And no matter how far we travel, we will ultimately remain alone in the vast expanse of space and time. Ultimately, the universe does not care about us. It doesn't care if we explore the stars, or if we discover alien life, or if we survive the inevitable death of our solar system. The universe will continue to evolve and decay, indifferent to the struggles of any civilization. The cosmic isolation we face is not a barrier we can overcome. It is a universal condition that no amount of technology, willpower, or ingenuity can change. As we look to the stars, the reality becomes clear. The universe is not just vast, it is indifferent. As we consider the ultimate fate of humanity and the long-term survival of any civilization, it becomes clear that the universe itself is an inherently hostile environment. The vast expanses of space, the relentless passage of time, and the inevitable decay of stars and galaxies ensure that no matter how far we stretch our reach, the very fabric of existence will eventually unravel. Even with the most advanced technologies and innovations, humanity's time in the cosmos is not infinite. The inevitable heat death of the universe, a state where all energy is evenly distributed and no usable energy remains to sustain life, ensures that eventually all life and everything that we know will fade into oblivion. There will come a time when there are no more stars, no more life, and no more activity. The universe will have expended all of its resources, and everything will be swallowed by the entropy that governs the cosmos. In this future, the hope of reaching distant stars or exploring alien worlds will be but a distant memory. As the expansion of the universe continues, the gap between galaxies will increase beyond the reach of any spacecraft. Stars will burn out, black holes will slowly evaporate, and the fabric of space itself will stretch thin, rendering even the most advanced technologies ineffective. The energy required to sustain life will become impossible to harness, and the cosmic isolation that once seemed like a distant fear will become the unavoidable reality. The idea of contacting aliens or even discovering new planets will be irrelevant because the universe will be cold, dark, and empty. In this scenario, humanity, or any civilization that might arise in the future, will find themselves facing an incomprehensible void. The very idea of space exploration will no longer be feasible because the gaps between galaxies will be so vast that no spacecraft, no matter how powerful, could ever bridge them. The expansion of the universe will have rendered us inaccessible to any other civilization, just as they will be unreachable to us. The future will not only be lonely, but also inaccessible, with the stars receding beyond the horizon of possibility. Even if humanity survives for billions of years, adapting to changing environments, colonizing other planets, and harnessing new sources of energy, the end will always come. The laws of thermodynamics, which govern the flow of energy in the universe, ensure that no system can continue forever. Energy dissipation will be the ultimate fate of all things. Even the most advanced civilizations will eventually run out of energy to maintain their existence. This entropic fate means that even the most intelligent species, even those with the most advanced technology, will eventually reach a point where their ability to sustain themselves becomes impossible. This relentless march toward entropy also affects the fabric of space itself. As time progresses, space will continue to expand, causing galaxies to drift apart at an increasing rate. This means that even if other civilizations exist somewhere in the distant future, they will become more and more isolated as the expansion of the universe drives them further from us. Even if technological advancements allow us to survive for longer, there is no escape from the universal law of entropy that governs the ultimate fate of all things. Perhaps the most devastating aspect of all this is that even if alien civilizations exist, we may never know them, and they will never know us. The expansion of the universe means that intergalactic travel will become impossible. It's not just the distances between stars that separate us. Space itself is expanding, stretching the very fabric of the universe and pushing galaxies further away. Any attempt to reach distant galaxies will eventually fail, as they are receding faster than any spaceship could travel. The communication between civilizations will be forever out of reach, as the distance between us will become insurmountable. The hope of meeting other intelligent species may simply be impossible. The universe might be teeming with life, but it is a life that will remain forever out of reach, separated by barriers of time, space, and energy. The dream of interstellar exploration, of finding alien civilizations and making contact, will become a distant memory, a relic of a past that was never truly achievable. We might never find out whether we are alone in the universe or whether other civilizations once flourished, only to be lost to the same cosmic isolation that now defines our existence. As the universe continues to evolve, one of the most profound realizations we must come to terms with is the absolute finality of existence. No matter how far we travel, how much we achieve, or how advanced our technology becomes, we will always face the cold, indifferent reality of the universe's expansion. The stars will burn out, the galaxies will drift apart, and the universe itself will reach a state where no life remains. All of our efforts, our struggles, and our hopes for exploration will ultimately be swallowed by the vast, empty void of time and space. In the face of these cosmic truths, we must ask ourselves, what does it mean to exist in a universe that is not only indifferent to our survival, but actively working to keep us isolated? Can we ever truly escape this isolation? Or are we destined to be alone in the cosmos, forever separated by the vast distances and the relentless passage of time? As we look at the grand scheme of time, we are reminded of one unyielding truth. Civilizations, no matter how advanced, eventually collapse. This collapse isn't always caused by internal failure, but by the relentless forces of the universe itself. It's not just about the struggles of society or the decay of technology. It's about the inevitable end of all systems in the face of the overwhelming forces of entropy and cosmic isolation. Every civilization, including ours, is bound by the same universal laws that govern everything from the formation of the stars to the fate of entire galaxies. In the end, time is both our greatest adversary and our greatest equalizer. The collapse of a civilization doesn't necessarily mean its sudden disappearance. In fact, civilizations may collapse slowly, gradually fading away as they face the immense challenges of maintaining their existence over time. This slow decline is often driven by resource depletion, environmental collapse, and the gradual breakdown of social systems that were once thought to be stable. Even the most advanced technologies, designed to extend the lifespan of a civilization and allow it to travel the stars, will eventually falter in the face of these existential pressures. The challenges of living in an ever-expanding universe are too great, even for the most resilient of societies. Consider the fate of humanity as we continue to advance technologically. It's possible that we will develop the ability to travel beyond our solar system, and perhaps even colonize distant worlds. But what happens when the technology we rely on becomes obsolete? When the systems that allow us to survive on new planets begin to break down? The larger issue is that all of our efforts to colonize the stars may still be bound by the same limits that have constrained us on Earth. Even if we find new homes on distant planets, the universe itself is vast and cold, offering little more than harsh environments and relentless challenges. The question then becomes, how long can any civilization, even one that has mastered space travel, sustain itself in the long term? The universe is filled with forces that are outside our control. Cosmic radiation, the slow death of stars, the expansion of space. No matter how advanced our technology becomes, we will still be subject to the natural laws of the cosmos. The more we venture into space, the more we encounter these unavoidable truths. The distances between stars are too vast, the energy required is too immense, and the time available is too short. The effort to conquer the stars may ultimately be a futile one, doomed to fail in the face of cosmic forces that no technology can overcome. What's even more striking is the idea that the collapse of civilization might not be a single catastrophic event, but a gradual fading into oblivion. As the energy resources we rely on dwindle, as our societies fracture, and as time wears down our technological prowess, we may find ourselves in an ever-decreasing loop. A civilization that once had the ambition and ability to reach the stars might eventually be reduced to a shadow of its former self, barely able to maintain even a fraction of the systems that once allowed it to thrive. The slow decay of these systems, compounded by the psychological strain of such long-term missions, would inevitably lead to a collapse. Not in the form of a sudden explosion, but in a quiet, invisible fade. In the larger context, this collapse isn't a failure of technology. It's a failure of the universe itself to support any kind of lasting, stable existence. We live in a universe governed by the second law of thermodynamics, which states that all systems tend toward greater entropy or disorder. The more complex a system becomes, and the more energy it requires to maintain itself, and the more likely it is to decay over time. In the case of interstellar exploration, this means that any spacecraft, any colony, and even any advanced civilization will eventually reach the point where maintaining their systems becomes impossible. This process of decay, driven by the increasing entropy of the universe, ensures that no civilization, no matter how advanced, can survive indefinitely. Perhaps one of the most humbling thoughts is that even if we do reach the stars, we will not be immune to this cosmic fate. The universe is indifferent to our survival, and no amount of technological achievement or societal advancement will change that. Even if we manage to colonize other worlds or develop the ability to travel vast distances across space, we will still face the same obstacles that exist here on Earth: limited resources, time constraints, and the eventual breakdown of systems. The dream of interstellar civilization may, in the end, be just that: a dream forever out of reach. the long-term survival of humanity and any civilization is ultimately bound by the laws of nature. No matter how far we advance technologically, we will always be subject to the same cosmic forces that govern the universe. And as the universe continues to expand and cool, those forces will become even more insurmountable. Whether we are a young species just beginning to explore the stars or an ancient civilization, the reality is that no civilization can escape the relentless march of time. No matter how much we try to overcome the obstacles in our path, we will eventually be swallowed by the infinite expanse of space and time. As we've explored the challenges of interstellar travel, cosmic isolation, and the long-term survival of civilizations, one overarching truth remains clear. The universe itself is indifferent to our existence. The very laws of physics, the distances between stars, and the passage of time ensure that no matter how much we advance as a species, we will always be confined by these fundamental limits. The dream of connecting with other civilizations, of traversing the stars, of becoming an interstellar species, remains just that, a dream, unattainable in the face of the universe's harsh realities. The universe is expanding, the galaxies are receding beyond our reach, and the cosmic isolation that we experience today will only grow worse with time. Even if other intelligent species exist, their communication or contact with us is highly unlikely. The sheer vastness of space, combined with the relentless expansion of the universe, means that civilizations, whether human or alien, will likely remain forever isolated. As stars burn out, galaxies collide, and space itself stretches apart, any possibility of intergalactic travel or meaningful communication becomes a distant hope, increasingly out of reach. In this context, the existence of intelligent life becomes more of a philosophical question than a practical one. It's easy to imagine that there are countless civilizations scattered across the cosmos, each facing their own challenges and successes. But the reality is that the chances of these civilizations ever meeting or even detecting each other are incredibly slim. The universe itself, with its immense distances, accelerating expansion, and the inevitable decay of stars and planets, guarantees that the universe will remain a vast, lonely expanse where the possibility of meaningful connections between civilizations is just as impossible as the prospect of interstellar travel itself. For us, as humans, the question becomes not about whether we can reach the stars, but about how we cope with the reality that our time in the universe is finite. Whether we survive for a few thousand years, or whether we manage to thrive for millions of years, the end will come. The universe will continue to evolve, and the forces that govern its expansion will eventually outpace any technological advancement we might achieve. There's no escaping the eventual heat death of the universe, where everything will be reduced to empty space, with no stars, no life, and no hope of survival. The universe will be a cold, dark place, with nothing left to mark the once great civilizations that roamed the stars. This cosmic inevitability poses a profound question. What does it mean for us as a species to live in a universe that is so vast, so indifferent, and so temporary? The dream of interstellar exploration, of finding other civilizations and connecting with them, might simply be impossible. The universe is simply too vast, too empty, and too inhospitable to sustain such dreams for long. Even if we could travel to the stars, we would eventually encounter the same relentless passage of time and the limits of energy that make it impossible to sustain any long-term mission. In the end, the harshest truth of all is that the universe will always remain a place of solitude and isolation. And no matter how advanced our technology becomes, we are still trapped within the constraints of space, time, and energy. The dream of a universal civilization, spanning across galaxies, exploring the stars, and meeting alien life, will remain just that, a dream. We may reach other planets, we may discover new worlds, but the cosmic isolation we face will always be with us. A constant reminder that we are alone in this vast, expanding universe. As the universe continues its slow march toward entropy, the dream of exploring the cosmos may fade away, replaced by the stark reality that we are not just physically isolated, but temporally isolated as well. The civilizations that might have once flourished will become nothing more than dust, are scattered across the vast emptiness of space. We will join them eventually, our efforts to survive, to explore, to understand, all lost to the infinite march of time. And yet, perhaps this is not all doom and gloom. Perhaps the temporary nature of our existence, our fleeting time in the universe, makes it all the more precious. Maybe it is our ephemeral nature that drives us to dream, to explore, and to seek meaning in a universe that offers so little. Our short-lived civilization will one day be gone, but for now we have the ability to look up at the stars and imagine the impossible, to dream of a future that may never come but is worth pursuing nonetheless. It's this hope, this desire to reach beyond our limits, that gives our species meaning, even if the cosmos itself will never care. The universe may be vast and indifferent, but the human spirit is resilient. Even as the universe expands, even as the stars fade and the galaxies drift away, we continue to strive toward something greater than ourselves, even if we know deep down that it may never be possible to reach. Perhaps that is the greatest paradox of all. Our quest for the stars is as much about our inner journey as it is about the physical distance we must cross. As we reach the conclusion of our exploration, one undeniable truth remains. The universe, in all its vastness, is both beautiful and indifferent. The dream of interstellar travel, of exploring distant galaxies, and of meeting alien civilizations may forever remain out of reach. The immense distances, the limitations of energy, the passage of time, and the expansion of the universe all combine to make such endeavors impossible. Yet, in the face of these overwhelming obstacles, it is the very act of dreaming, of striving, and of reaching for the stars that defines humanity. The universe may be vast, cold, and indifferent, but our ability to wonder, to question, and to imagine a future beyond our current limitations is something that will always drive us forward. Even though the dream of reaching other civilizations or traveling across the stars may seem impossible, it is our desire to push beyond the known, to explore the unknown, and to seek meaning in an ever-expanding universe that gives our lives purpose. While the cosmic isolation that we face may never disappear, our quest for knowledge, for understanding, and for connection remains unbroken. Even if we cannot touch the stars, perhaps it is enough to look up and dream of what could be. The universe may be a place of solitude and isolation, but it is also a place of incredible beauty and mystery, one that we will continue to explore, no matter how small we are in the grand expanse of time. In the end, the true journey is not necessarily about reaching the stars, but about the pursuit itself. And though we may never truly connect with extraterrestrial life or journey to the farthest reaches of the universe, our imagination and curiosity are what make us uniquely human, and that alone is worth exploring. So, as we continue to look to the stars, we carry with us the knowledge that even in the face of cosmic isolation, our dreams will keep us moving forward, ever hopeful, ever curious, and always reaching for the impossible. Thank you for joining us on this journey, and remember, the universe may be vast and unyielding, but we are not alone in our quest to understand it. Keep dreaming, keep wondering, and keep exploring.